Hello, students. After completing the ambiguous grammar, today we will discuss about the simplification of context-free grammar. So now we will start the simplification. So the point is why we require to simplify the grammar. So simpler grammars are easier to understand, first thing. And second is important point is the simple grammars can lead to faster parsing, or the simplex grammar will be the will have the less computation time, or the less time complexity. That's why we have to require to simplify the grammar. So now simply it will consist of different phases. So like the useless symbol elimination means just to find the useless symbol in the given grammar, then we will eliminate the useless production of that particular symbol. And then the same thing can also be called as the reduction of the grammar. And another is the elimination of the null production. If there are any null production in the grammar, then we will also eliminate such type of production from the grammar. And another is the unit production elimination, means if there is any unit production also in the grammar, then we will eliminate it, right? So now just useless symbol means, just I will discuss one by one. Null production means if any production in the form of this one, that a variable produce the null, right? So this type of production is simply said as null production. And unit production means any single variable produced to the single variable again, and simply this variable b again produced to another variable, this is suppose c. So these type of productions are called unit production. This All these productions are the unit production, and a to null is the production of null production. Now we will start the useless production elimination. So just we will try to find the useless symbol in the grammar, then we will try to reduce or eliminate the useless production. And the same thing can also be considered as, or can be said as construction of the reduced grammar. Means simply if we remove or if we eliminate the useless production from the grammar, then obviously we will find a grammar, and that grammar will be the reduced grammar. So now the point is, how can we identify that that a particular symbol is the useless symbol and the production is useless symbol, useless production. So let's start with the simple example, then we will start the same thing by using the theorem. So simply suppose a grammar is given to you, and in this case, suppose S to ASB, C, AC, and A to AB, B to this one. Now, if we start with S, then we can move in this direction, ASB, or we can start with S to AC, right? Because these productions are given to you, right? If you again want to expand this particular S, so you can terminate it by C, or you can expand it by AC, or you can expand it by AB. Clear? Or in the same way, if you want to expand this AC, then the production of A is given as AA, so you can expand by AA. But never you can reach on B production. So that means simply you can say that B symbol is the useless symbol in this given grammar. And all the productions of the B, or the all the productions of the B symbol are can be called as the useless production. So we can eliminate such type of productions in the grammar. So now this is we have done this thing by manually, but the same thing can be done with the help of the algorithm also. So for doing the for removing the useless production, just we will use the defined theorem. So for that purpose, we will start with the theorem, that the theorem is derivation of an equivalent grammar G dash from the context-free grammar G, such that each variable derives some terminal string. It means we have to start with the terminal string, means just create the set of all the variables those are producing terminal. So simple. In this theorem, we will start our production. We will start our process through the variable those are producing terminal. So this is the simple way, or this is the simple theorem by which we can reduce the grammar. So this is step one, or step theorem one, in which we have to try to construct the set of variable, that is v1 dash equals to a. A is what? A is the a belongs to variable where there exists a production a to w, where w is what? W is any string or the terminal, that w, where w belongs to terminal star, means w is any terminal. So simply start with the set of variable those are producing terminal. First point. Second point is just we have to calculate vi plus 1 dash, means suppose v1 dash, then we will calculate v2 dash, v3 dash, v4 dash, until we will find vk dash is not equals to vk plus 1 dash. So simply now we will try to find another one, that is vi plus 1 dash, generalized form of the set of variables, that is v1 vi dash union a to v, where v is what? V is the variable. There exists some production a to alpha, with alpha belongs to terminal union vi asterisk, vi dash whole asterisk. So what does it mean here? Just you should keep your mind, keep your focus on this point. That's this point is what? This point is just suppose you are calculating v2 dash. In this situation, you have to write here v1 union. Now the production terminal union v1 combination produced by the variable. Just we have to write the name of the variable here. Those are producing v1 union terminal whole asterisk, right? So in this way, the same process will be executed till we can find vk dash is not equals to vk plus 1 dash, right? And finally, we will write the construction of p dash, that is the new production rule for that grammar, in such a way that p dash is equals to a to alpha, where a to alpha and a, their alpha belongs to v dash union terminal whole star, means all the variables those are in the set and all the combination of terminals. So we will include such type of production rules in the grammar. So this is simply the step one for reducing the grammar, or for removing the useless symbol. Clear? So now just we will try to apply the same step on the real life, this particular real example of the grammar. So suppose a grammar is given to you. In this case, you can find the grammar here: S to AB, A to A, B to B, B to C, and E to C, right? So as per the theorem 1 or the step 1, just we can start here by step 1. And just step 1, we have to create the set of variable those are producing terminals. So the first point is to try to find the variables those are producing terminals. So here you can see that C is the terminal produced by E, another terminal is B produced by B, another terminal is A, that is produced by A. So simply just write the name of the variable those are producing terminals. So for example, here this is A, here it is the name of variable is B, and here the name of variable is E. So just write here A, B, and E. Clear? Now we will try to find v2. So v2 is what? v2 dash or v2 whatever, it is just v1 dash union terminal of terminal and v1 dash whole asterisk produced by any variable. So just you have to note it down, you have to write down the name of variable that is produced by this set. So here just try to find out that AB, AE, BA, BE is produced by any other variable. So here you can find that AB is produced by S. So you can include here S, right? Again, V3 dash, in V3 dash, similar to V2 dash, just here we will write V2 dash union terminal union V2 dash ka whole asterisk. That means is anything is produced by anyone, that is AB, AB is produced by S, we have already included it, and BE not provided by any other variable, ES, SE, SB is not provided by any other variable. That means V3 dash is equals to V2 dash. So finally, it will be the set of variables. That is, we can write here S first, because S is the start symbol. So S, A, B, and E. Now, just write the production rule for that. So these are the variables, that is A, S, A, B, and E. In this case, you can see easily that S, C variable is not present in our received set of variable. So we will eliminate such type of variable or such type of production. So just see, S to AB, S is given to you, AB is in the set. So just S to AB will be included in the production set. Next is A to A. This is the terminal. So thus A is already in the set. So just write here. B is just we have to write here, and B to C. So in this case, you can see especially that C is not the part of set of variables. So we cannot include this production because C is not in the R variable set. So we will discard this particular production rule. And E to C, it is already there because E is there and C is the terminal. So now by apply the step 1, we can find that we can reduce the grammar by one production rule, B to C, because C is not, C is the useless symbol in this particular grammar. So we can eliminate, we can remove this type of symbol. So I think it is clear. Now, this is the step 1 actually. So after this, we will apply another theorem, that is step 2. So for example, suppose any grammar G is given to you. Just I want to discuss the whole thing by giving the simple diagram. Suppose initially G's grammar is given to you. Now you have to apply theorem 1. Then you will find the new grammar or the reduced grammar, that is G dash, similar as this one. So this grammar will be the G dash, right? On G dash, again we have to apply theorem 2, and finally we will find a reduced grammar, that is G double dash. So our objective is to find G double dash through G, right? So in this case, we have to follow the step, that is step 1, then step 2. So now we have completed step 1. So just we should start the step 2. So step 2 is the, or you can say the phase 2. This is again a theorem that is used to derive some string, terminal string. So now just step 2 is derivation of an equivalent grammar G double dash from the context free grammar G dash, as I already shown you through the diagram, such that each symbol appears in a sentential form. So now just start with the construction of V double dash, means set of variable. So simply just we will start V1 double dash with start symbol S, right? And then we will try to find B2 dash, B2 double dash, and B3 double dash, similar to the previous one, but in this way. That is Vi plus 1 double dash is equals to Vi double dash union X belongs to V dash, where there exists some production A2 alpha with A belong to V1 double dash and alpha contain the symbol X. So it is just similar that if V1 contains suppose S, now we will calculate suppose B2, that is S, and all the variable or terminal that is produced by S. So we will write here the production that is produced by S. And we will do the same thing again and again until we can find Vk double dash is not equals to Vk plus 1 double dash, right? And similar to the previous one, just we will construct the production rule for all the variables that are in the set. So see here, how can we apply this type of theorem? So this is the same example. S to AB, A to A, this is given to you. And after apply the step 1, we can find the reduced grammar, that is G dash, in this way. So as you already seen the same question, that B2C production is eliminated in step 1. Now we are going to impose step 2, or we are going to apply step 2 on the reduced grammar, that is G dash, right? So here start with S, as I already told you. Now just see what symbol can be produced by S. So V2 double dash is S and symbol produced by S. That is S can be produced A and B. So just write here A and B. And finally, again, just we are going to calculate V3. So V3 is equals to SAB union anything else that is provided by A and B and S. So simply S is provides, S will provide you AB. AB is already here. A is provide small a. This is the terminal. So this that cannot be stored in the set of variable. And B is small b, that is again terminal, so not in, that cannot be included in this set. So the set of variable will be finally that is SAB, and SAB is it is already calculated or obtained in B2. So B2 and B3 are the same. So we should stop here, and this is the final set of variable that is S, A, and B. So you can see here clearly that E is not here in the set of variable. That means E is also the what? E is also the useless symbol, and the production E to C will be also the useless production. So just write the production of all the variables. Those are present in the set. So for S, you have to write S to AB. A and B both are present. So just it is finalized. A to A or B to B. This is the terminal. Just we will write here A to A and B to B, and E to C is not should not be included because E is not a member of this group. So finally, after apply this step 2 or theorem 2, we can find the reduced grammar. So in each and every question, if anyone asks you to find the reduced grammar, so start with G. Then after applying the theorem 1, that you will find grammar reduced grammar G1, and finally after applying step 2, you can find the reduced grammar G double dash. So you have to follow all these. You have to follow all these rules. Thank you. Thank you.